Okay, second video is the study guide. So this is, I'm going to walk through all the problems on the study guide rather quickly, but just pause it and replay it if you need to. I'll be here Thursday after school, so the day before your test if you're A-Day. If you're B-Day, you can come in the morning if you have last-minute questions, but hopefully this video is going to make sure that you don't have any. Okay, so the distance between 2 points, we can do the distance formula, which you do need to memorize if you are going to use that method. These formulas are not going to be given to you on the end of course exam. Or you can use the Pythagorean theorem. That is much quicker if you can understand the difference between them. So the x2 minus x1 is very similar to what we were doing on the partition one if you watched that video, but we're taking the x1, y1, that's the first point, and then x2, y2. We're taking those points and plugging them into this formula, but what we're doing mentally is figuring out 1 minus negative 3 is 4 units, so that would be my horizontal shift for my Pythagorean theorem. 0 minus 8 is negative 8, so it's 8 units. I can put negative 8 or 8, doesn't really matter for B. I don't usually write negatives because when you square it, it's going to be positive anyways, so there's no point in putting a negative. Not much of a point in putting a negative. So if we do a squared plus b squared, it's going to equal c squared. When we find the distance, we just want c. We don't want c squared. So we do have to square root it at the very last step, but we'll get to that. So if we do, I'm writing really tiny. So 4 squared, 16 plus negative 8 squared is the same as 8 squared, so 64. You should never get negatives at this point for the distance formula. The distance is always going to be positive. And then you square root once you add these together, so 0, 1, 80. So the square root of 80. Okay, so it's to the nearest hundredth. So we look at the thousands place, which is the third place after the decimal. If this is a 4 or lower, this stays still. If this is a 5 or higher, this changes to the next highest number. So this would be 4, since it's 4, it's 8.94, it stays as a 4. Okay. If you did the distance formula way, you would plug in with your labels. Okay, x2 was 1, x1 was negative 3, y2 was 0, and y1 was 8. Okay, so you get 1 minus negative 3, which is 4 squared. 0 minus 8, which is negative 8 squared. So this is the same thing that you're getting for A and B. We're just actually having to do all of the work out, versus Pythagorean theorem means you can do some of it mentally. You can figure out the distance between x coordinates and y coordinates mentally. But when you get to this step, it turns into this, so you're going to get 16 and 64. So 80 square rooted is about 8.94. Partition. Find the point that partitions the segment into segment CD, so those are our endpoints, into a 3:2 ratio. 3 plus 2 is 5 total parts. C is at 4, negative 6. D is at 19, negative 1. We want 3 parts before, so we want P to be here, or the partition point to be here. So in x, if we do 19 minus 4, that tells us how many units are between 4 and 19, and the sign and everything that we want. And we're dividing that into 5 parts. So that's 15 divided by 5, which is 3. So we're increasing 3 units every time. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, 16, 19. Good. Y, we went from negative 6 to negative 1, so we do negative 1 minus negative 6 over 5 parts. That's the total amount of parts. So 5 over 5 is 1, so we're increasing 1. Negative 5, negative 4, negative 3, negative 2, negative 1. So our answer would be 13, negative 3. Okay, for number 3, you're finding the length, which is synonymous with distance, so it means the same thing as distance, so the distance between A and B. So it's very similar to number 1, except for they don't give you the coordinates this time, they give you a graph. Definitely on a graph, Pythagorean theorem is going to be quicker and less erroneous. So 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5 units away. So that's my A. It's 1, 2 units up. So that's my B. So your horizontal and vertical shifts are your A and your B of your Pythagorean theorem. Then you're going to plug into the formula and solve. So 5 squared is going to give me 25. 2 squared is 4. And to the nearest tenth, I'm going to look at the hundredth place. It's an 8, so I round this up to a 4. So it's 5.4. Okay, what are the coordinates of H if M is the midpoint? Okay, so M is the midpoint of segment HT, and T is at 5, -1. So as long as you put M in the middle, then you can do your shifts. So 5 to 2, and you're going to start with the end. Start with the end. Almost always you start with the end. Even on the distance formula, you start with the end. When you're subtracting in the partitioning, you start with the end, subtract the front. But then you do start with the front when you do the shift, so that could be a little confusing. So start with the end on this and go towards the middle, and then go towards the other end. So 5 to 2, you're decreasing 3 units. So we want to drop 3 units. 2 minus 3 is -1. Increasing 4 units from -1 to 3, so we want to increase 4 units, and we land at 7. So H is -1, 7. Okay, if Y is the midpoint, that means that QR is cut in half, where QY is equal to YR. That's only true if the point Y is the midpoint. Then these two things are equal. So QY equals YR, so we can set them equal and solve for X. So this is the algebra. I'm going to do the minus 4x in the same step as I add 23. So I'm moving the 23 to the left side, the 4 to the right side. So that's 15 equals 5x, so x is going to be 3. And we want to find QR. So don't stop when you get an x. You have to make sure you answer. Sorry, we want to find QY. So we want to find out what this is. Well, QY is equal to 4x minus 8. But we know x, so we can plug in x of 3 and evaluate. So 12 minus 8 is going to give us 4. So our answer for the problem is 4, not 3. What is the midpoint of HR if the endpoints are -2, -1, and 8, -5? So midpoint is the average. Okay. So we're just going to use the midpoint formula. Okay, so we add the two x's, so -2 plus 8, cut that in half, add the two y's, cut that in half. So 6 over 2, which is 3, -6 over 2, which is also 3, but it's a negative. Okay, so this one I give you some expressions for different things. So they don't tell you that B is the midpoint, so we can't assume AB is equal to BC. Can't assume it. So we have to use our segment addition. So AB, anytime you have 3 points on a line segment, the distance between the first 2 points, so AB, plus the distance between the second 2 points equals the distance between the first and third point. It's just like in football, like when you have a possession. You start on the ball on spot A on the field. In the first down you get to B. In the second down you go from B to C. So for the possession you went from A to C. That's what we're doing. Then we're substituting in the expressions. And from there it's algebra. So we want to combine like terms on the same side. So we have a total of 6x, -5, and 10 makes plus 5. Then we want to subtract 3x from both sides. That is going to move it from this side. So then I want to move the 5 next, but I can do them in the same step. So I can subtract 5 from both sides here. So that cancels. And I have 3x equals 9, so x is 3. And they want us to find BC. and they give us an expression for BC, so that's nice of them. So 2 times 3 plus 10 is what BC is going to equal, so 6 plus 10 or 16. Find the perimeter of the triangle below. So perimeter means sum of the sides. So we need to figure out what DE plus EF plus DF equals. So we can count EF, that's easy because it's got a horizontal, it's easier on the computer because the numbers are more clear. So it goes from 2 to 6, so it's 4 units. This one goes from 3 to 7, so it's also 4 units. But diagonal sides we can't count, so we know 4 and 4 for these. But this diagonal side we're going to have to do the Pythagorean theorem. So for DE, we need to figure out the horizontal shift and the vertical shift, which happen to be the two sides of the triangle, so 4 and 4 are our shifts. So to get from point E to point D, you have to go over 4 units and up 4 units. So when you do A squared plus B squared equals C squared, you get 32 equals C squared. Square rooting that, you get the square root of 32, which is 5.656 and some other numbers. Then just hit plus here. Don't clear it out and put 5.65. Don't do that because you want to round only at the very end. So if these had been radicals, you wouldn't want to round it early. So then just hit plus 4, plus 4. And we're rounding to the nearest tenth, so we want to look at the hundredth. It's 5, so we round this to 7. Find the area. So for the triangles, we have areas base times half base times height. If we can find a flat side that to be our base, that's ideal. And then our height is going to be the distance from the top point to that flat side. So if I turn the paper like this can be my base. Oops, this can be my base, and this can be my height, because it's going from the flat side, the horizontal line, which I can count, straight up to the tallest point. So this is 3 units. This is 1, 2, 3, 4, 5, 6, 7 units. So my base and height, so it's 7 and 3, put them upside down. My base would be 7 because that's the flat side, and then the height from that flat side to the top point is 3. So 1/2, 7 times 3, so 1 divided by 2, so 0.5 times 7 times 3. This is 10.5. You don't square the 10 or anything, it's just units squared because we did units times units, but you don't have to square anything. Find the perimeter of the quadrilateral to the nearest hundredth. Okay, so we have perimeter against the sum of the sides. So AB plus BC plus CD plus DA. So we're going to be doing the lengths of all 4 sides. Any side that's horizontal or vertical, we can just count. So we can just count this side. It's going from -3 to 3, so it's 6 units. It's going from -4 to 5, so this is 9 units. So AB we already know, and CD we already know. So we just got to figure out the 2 slanted sides. So to do that, we need the Pythagorean theorem or the distance formula. So you can do the distance formula. I'm going to do the Pythagorean theorem. So for AD, to get from point D to point A. So all I'm looking at when I'm solving this is this segment. I'm ignoring everything else in the picture for just a second. So from this segment, D to A, I have to go over 1 unit to get from D to A, and up 3 units. So my A of my Pythagorean theorem is going to be 1, and I said up 3 units, so my B is going to be 3. So when I do A squared plus B squared equals C squared, I get 10 equals C squared. So the square root of 10 equals C. So this side is the square root of 10. Then we do the same process for BC. Okay, we want to look at how many units does it go over? 2. And how many units does it go up? 3. So A is 2, B is 3. Squaring those, we can add them together and get 13. So the square root of 13 is this side. Okay, so perimeter, we want to add all this together. So we're going to do 6 plus 13 radical plus, we don't even clear anything out, 9 plus 10 radical equals 21 point, we want to the hundredth. Thousandth is higher than a 5, or 5 or higher, so we round this to a 7. Okay, point A, okay, then the partitioning one. So point A has coordinates of -3, -2. Point B, 7, 2, and find the coordinates of P that are 3/4 of the distance from A to B. So they're telling us the distance from A to B is fourths. Sorry, that doesn't really look like fourths, sorry. It's late. Okay, so 3/4 of the distance. So we want to figure out what the point here would be. Alright, so what we're going to do is look at the x coordinates first. So from -3 to 7, it is a 10 unit swing. And I'm dividing it into fourths. Okay, so 10/4 simplifies to 5/2. So I can use 5/2 instead of 10/4. You can use either fraction. Okay, in order to add fractions, I need that common denominator, so I'm going to multiply this 2 times the -3 to get my new numerator. So -6 over 2 is an equivalent way to write -3. Now I'm going to be adding 5 to the numerator and keeping the denominator over 2 every time. So -6 plus 5 is going to give me -1, plus another 5 is 4, plus another 5 is 9, plus another 5 is 14, which is equivalent to 7. 14/2 is equivalent to 7. Okay, for y, we go from -2 to 2, so 2 minus -2 is gloriously 4 over 4, so we're just going to be increasing 1 every time. -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 2. So our answer is going to be 9/2, 1. Element are collinear, so same line. And M is between L and N. So we don't know how close it is to either one, but we know L and N are on the outskirts and M is somewhere between them. Okay, so then they give us Mn is 5x plus 5, Lm is 2x minus 9, and 3x plus 20 is L all the way to N. So we need our segment addition equation. So we can't use the midpoint equation like setting these equal because we don't know where M falls along here. It could be closer to L, could be closer to N, we don't know. So we have to use the whole football analogy. So first down plus second down equals total possession. Substituting in, we get 2x minus 9 plus 5x plus 5 equals 3x plus 20. And then you can solve the algebra. So you can pause it, solve the algebra, and then plug back into Mn because they want Mn. I'm going to do the algebra here just real quickly. Okay, I get x equals 6. So if I plug in 6 to Mn was 5x plus 5, but I want to plug in 6 for x. So 30 plus 5 is 35. Same thing for 13 is 12 really. So DE plus EF, first down plus second down equals total possession. Combining like terms and solving for x. So I'll let you do that, pause it, and solve it, and then you can scroll past where I am. And I want DE. So after you get x equals 4, you're going to plug it in for DE, this expression. And you get 29. Okay, if line Y bisects AC, so line Y is cutting AC in half. That means that this is the midpoint. Since it's getting cut in half right here, this is half and this is half. two halves have to be equal. Somebody gets half of the pizza and you get the other half. Their half isn't bigger than yours. They're equal. So AB equals BC. And that's the equation that you substitute into. So you substitute in AB and substitute in BC and solve. Okay, then we want to find AC, so we don't have an expression for AC. We can plug it into AB and into BC and add them together because AC is the total of AB plus BC. So 15, 4 minus negative, well, really 4 plus 15. So 19 and negative 6 plus 29 is also 19. So 38 would be AC. Because it's the combination of these. You add them together because A to B plus B to C equals A to C. So 19 plus 19 is going to give us 38. Okay, when it says find PQ like this, we're looking for the distance between P and Q. Find BC, looking for the distance. I'm getting ahead of myself, but there's so much distance stuff on here. So you can do the distance formula or the Pythagorean theorem. Again, distance formula, you need to memorize it if you're going to use that. There it is. Pythagorean theorem, that's what I'm going to use. 1, 2, 3, 4, 5, 6, 7. So I'm counting segments. There are 7 segments from Q to get to P. B, there are 1, 2, 3 segments. So A squared plus B squared equals C squared. 58 equals C squared. Nearest tenth. 1 keeps this as a 6, 7.6. Find the coordinates of Z if Y is the midpoint. Okay, so Y is the midpoint. It means there's an X and a Z on either side of it. X is negative 10, 9. So we're looking for the whole shift thing. Negative 10, so we're starting with the endpoint, which is X. Negative 10 minus, or to get to negative 4 is an increase of 6, so we want to increase 6 units and land at negative 2. 9 to 8 is a decrease of 1. Decreasing 1, we get, oh, I forgot my book. Okay, sorry, that was random. Negative 2, 7. Okay, distance, I'll do the distance formula for this one since I've been doing tons of Pythagorean theorem, just in case distance is your preferred method. Okay, so x1, y1, x2, y2. So x2 is negative 4, x1 is 8, y2 is negative 2, y1 is negative 7. Feel free to pause this. I know I go quickly. Pause it. Try it yourself. See if you can get the answer. Negative 12 squared, 5 squared, 144 and 25, 169, which is a solid 13. Okay, we got another perimeter one. And I'm picking it up a little bit, the pace, because I have somewhere to be. Okay, so only side that we can just count is BC, unfortunately. That's the only vertical or horizontal side. It's 4 units. A, B, my shifts. So I have 4 units over, 1 unit down. So A is 4, B is 1. A, D, I have 1 unit over, 3 units up. And C, D, I have, well, negative 1, so 5 units over, 2 units up. So A squared plus B squared, square root is going to be the square root of 17. A squared plus B squared is going to give me the square root of 10. A squared plus B squared is going to give me the square root of 29. Okay, so those are my side lengths I have to add together. So the square root of 17 is this. Leave it exactly like that in your calculator. Don't hit equals and round it or anything early. Hit plus 4 plus 29 radical plus 10 radical. Okay, you're not rounding early. So to the nearest tenth now is going to be 16.7. Okay, a couple more left. 19. Find the area. So this is tricky because you have to break it up into triangles, and we want to find sides that are horizontal and vertical if we can. So I'm going to divide it. If I try to divide it here, then I have a vertical and a horizontal side, but I don't, like, this is going to end in the middle of a coordinate, so I don't really want to do that. I want it to end on like a perfect whole coordinate or integer. So I want to divide this triangle here. Then I can divide this triangle here. That will end on a -3, 2 coordinates. That's good. And then this triangle here. So we actually have like 4 different shapes we have to do here. 1, 2, 3, 4. So you have to find the area of all the triangles and the area of all the, well, just one rectangle, and then add them together. Okay, so if we do the area of a triangle, it's 1/2 base times height. And the area of the rectangle is just base times height. So the area of the rectangle is probably the easiest to start with. We have 4 units times 2 units. So the base of the rectangle is 4 and the height is 2. So the area of that rectangle, which is the 4th shape, is 8. Okay. So we're going to be adding areas 1 plus area 2 plus area 3 plus area 4. And the area of 4 was 8. Okay, the triangle for number 1, we have a base of 1, 2, 3, 4, 5 units and a height of 1, 2 units. So 1/2, so 1 divided by 2 times 5 times 2 is going to give us 5 for the area for 1. For the second shape, this is for 1, this is for 4. For the second shape, we have a base of 1, an area and a height of, it goes from 2 to 5, so 3. So this is for shape 2. So 1/2, or 0.5 times 1 times 3 is 1.5. This one's a base of 4 and a height of 1. This is for shape 3. So 0.5 times 4 times 1. This is just going to be 2. So my area is going to be 10, 15, 16.5. Okay, last one. Oh no, the green lady's back. Okay, I gotta hurry. She's gonna get going. A, B, and C are collinear on segment AC. So AC is this segment. A, B, so this is up to B is 2 parts, and then B to C is 3 parts. A is located at 310, B is located at 6,4, and we want to know the coordinates of C. So we want to only treat this as if it's partitioned. Basically, it's a midpoint because we have just 2 sections. So we're finding the middle of these, which you can figure out the middle of 3 and 6 by adding, dividing by 2. We'll do it partition way because this is a partition problem. But you could find the midpoint and then keep that pattern going. So anyway, if we do partition way, we have 6 minus 3, so it's a shift of 3 units that we're dividing into just 2 parts. So 3 over 2, which is 1.5. I'm going to use the decimals this time to show you that you can if the fraction divides evenly. So not evenly, but where it's not repeating a repeating decimal. So we're going to be increasing 1.5 every time for the x. So 1.5 is going to be 4.5, 6, 7.5, 9, 10.5. Okay, for y, we go from 10 to 4, so 4 minus 10 over 2 parts. That's how many parts are between A and B only. So negative 6 divided by 2 is gloriously 3, a whole number, well, an integer. 10 minus 3, 7, minus 3, 4, minus 3, 1, minus 3, negative 2, minus 3, negative 5. And that is the study guide.